In this video, we are going to explain how to use Laplace transform to solve a linear constant coefficient differential equation. In this example, the linear differential equation is defined by this equation: dy by dt plus 4y of t equal dx by dt. X is the input and y is the output of a linear time invariant system. And the input is sine 2t ut and the output y of t that we need to find, and but the initial condition is known as equal to 2. The question has two parts. The first part, find the overall response, and the second part, find the zero input response. For the first one, to find the overall response, it means find y of t when input is equal sine 2t, and include those the initial condition too. The first thing you'll do is just write the differential equation of the system, which is equal dy by dt plus 4y equal dx by dt. And then you find Laplace transform for the whole equation. For 4y, it's easy. Y of t, the Laplace is equal y of s, and then you multiply 4 here, constant. What about dy by dt? You got to go to property of the Laplace transform when you do the differentiation. If y of t by Laplace transform will be y of s. So if you have dy by dt differentiated, so you will have multiplied by s. Multiply this by s, and then you subtract the initial condition. And the initial condition in this matter is equal to 2. It is given in the problem here. So now I know this part is equal to s y of s minus 2. So what's left here? The differentiation of the input. The input is given in this problem. X of t is equal sine 2t ut. You got to look for the Laplace transform pairs. You find that the sine omega t, it's be like that, omega over s square plus omega square. So accordingly, x of s will be equal to, omega here is equal to 2. So 2 over s square plus 2 square is equal to 4. So that will be x of s. But here in this equation, dx by dt, again we're going to use the differentiation property. So the differentiation of dx by dt will be equal to s x of s minus the initial condition of x0. Already it's given. It's sine 2t ut. So at 0, if you put here 0, you will have sine 0, which is equal to 0. So this value is equal to 0. And sx of s, you have x here equal to over s squared plus 4. So in this case, you will have s times 2 will be 2s over s squared plus 4. And that will be the Laplace of the differentiation of dx by dt. So you have here 2s over s squared plus 4. So you have the equation now. Sy of s minus 2 plus 4ys equal 2s over s squared plus 4 to find the overall response. Let's go ahead and write the equation. So you have s y of s minus 2 plus 4y of s equal to 2 of s squared plus 4. Remember, we want to find y of s, so we have to collect the terms that has y. So you have y of s, and the common factor here is s plus 4 minus 2 left, 2s s squared plus 4. So s plus 4 y of s, you move this one on the other side, 2 plus 2s over s plus 4, have a common denominator, s squared plus 4, and this 2 multiplied by all thing here. So you have 2s squared plus 8, and then you got here 2s. So that's what you got. So what's y of s? You divide by this guy. So you have y of s is equal to 2s squared. Or we can go ahead and simplify it, because you can see here you have 2s squared plus 8 plus 2s. You got 2 as a common factor. Go ahead, take 2 as a common factor. You have s squared and rearrange it, plus s plus 4. You have s squared plus 4 here, and you got divided by s plus 4. So that will be the equation of the y of s. So what you will do, you are going to do the partial fraction using inverse. Of course, you have s squared plus 4, s squared plus 4, and s plus 4. That's a simple one. So you say s plus 4 will have constant, call it for example constant a, plus you got this guy s squared plus 4. So you have polynomial, the numerator should be polynomial of first order, which is like bs plus c. So see, it's just function of s, as you see here, linear function. And our job now to do the same thing that we did in other videos, how to find the inverse. It's easy to find a. How you find a? You look for the expression of y of s. You just write, let me just write here, 2 s squared plus s plus 4 divided by s squared plus 4 plus s plus 4. Now you want to find a, and the denominator of a is s plus 4, so you just erase it from here. And then you substitute by s equal to minus 4. Why? Because s plus 4 is equal 0, s equal minus 4. And find the value after s by s is equal minus 4. Find the value of a. You'll find it's equal to 1.6. All right. So that's the first element. Now we need to find bs plus c. So what should you do? Well, you can do you have a common denominator, and then you compare between the two. Then if you do the same thing, and you can watch the other video that will explain it, you'll find that b is equal to 0.4, and c will be equal to 0.4 also. So you get both equal to 0.4. All right. So now let's just write the expression we got now, y of s after the partial fraction. You have a is equal 1.6 over s plus 4. And you got 0.4 s over s squared plus 4. And you have 0.4, but you have s plus 4 and 0.4. All right. We know that that's easy to find the inverse. If you want to find 1 of t, that's easy, because you have 1 over s plus 4 equal to the inverse of this one is equal e minus 4t ut. And you got the constant here 1.6, so you have 1.6 here. So that's the first guy. And this look like a cosine 2t. Remember, this is omega squared, and omega is equal to cosine 2t ut. And you got the constant in the front, 0.4. And this guy, since omega is equal to, you should have 2 here. So what should you do? You can say that here, that's here 2. And here you put 0.2. So that will be the equivalent. So this is a sine 2t omega t ut, and the constant here 0.2. So that's, I mean, the third term. So you got the solution now, y of t is equal to 1.6 e to the minus 4t ut plus 0.4 cosine 2t ut plus 0.2 sine 2t ut. So part A is done. All right. Part 2, in the same example here, they ask about find the zero input response. What does it mean, zero input response? Let us just write here. Zero input response is corresponding to when the input x of t is equal 0. We have the equation, we did that before, so I'm not going to redo all the things, just we'll go for the equation that we did. That's what we did, all right? That's the Laplace of everything, except only now, if x is equal 0, so the x by dt equals 0. So I mean, you say you have sys minus 2 plus 4ys equal 0. That's, I mean, zero input. Let's write equation. In this case, so you will have sys minus 2 plus 4ys equal 0. That's the mean zero input. You have to take the common factor, so you have s plus 4 times ys is equal minus 2, but 2 on the other side. So you have y of s is equal to 2 over s plus 4. That's the equation of the y of s. And now we need to get the inverse of this one. That's very simple. Y of t is equal, because this one you can write it 2 times 1 over s plus 4. This guy is equal to e to the minus 4t ut and the constant 2 in the front, and that will be the answer for the question. All right, thank you.